Types of variation, joint variation. If there are more than two quantities involved in a variation where both types of variation are present, then we are dealing with a joint variation. For example, the quantity x may vary inversely with a quantity y, and directly with another quantity z, to form a joint variation. In such cases, we can write for two different situations, 1 and 2, we have the following shown on screen. We also obtain the following shown on screen, where k is a constant of proportionality as usual. Dividing the two previous equations side by side, we have the following shown on screen. Simplifying k from both terms, we have the following shown on screen. The general rule of joint variation is that the two quantities that are at the same side of the formula vary inversely, while each of them varies directly with the quantity that is present at the other side of the formula. Example 1. 10 workers can build 5 houses in 12 months. How long it takes to 15 workers to build 8 houses? Solution 1. Increasing the number of workers brings an increase in the number of houses built during a certain time. Therefore, the number of workers varies directly with the number of houses built. Yet, increasing the number of workers brings a decrease in the time taken to build a certain number of houses. Hence, the number of workers is inversely proportional to the time taken. Finally, increasing the number of houses increases the time taken to build them. Therefore, the number of houses is directly proportional to the time. Since the number of houses is directly proportional to each from the other two quantities, it must appear alone in the formula, while the other two quantities must be together on the other side of the formula, multiplied with each other. Hence, we have the following shown on screen. Substituting the known values results in the following shown on screen. Applying the cross product results in the following shown on screen. If there are more than 3 quantities involved in a variation, we must carefully analyze which of them vary directly, and which inversely. Then, the appropriate expression is written by observing the previous mentioned rules. Example 2. 18 men can build 5 houses in 3 months by working 6 hours a day. How long will it take to 27 men building 12 houses by working 8 hours a day? Solution 2. Let's express the information in a table for a better understanding. We have the following shown on screen. Let's focus on the missing quantity z, and check what kind of variation it has with the other quantities. 1. More people working equals less months needed to build a fixed number of houses. Thus, x and z vary inversely. 2. More houses built equals more months needed if the other variables remain unchanged. Thus, y and z vary directly. 3. More hours a day committed equals less time needed to build a fixed number of houses if the number of people is constant. Therefore, z and t vary inversely. Combining all the previous findings, we write the following shown on screen. Where k is the usual constant of proportionality. Writing the previous expression for the two situations, 1 and 2, results in the following shown on screen. Or we obtain the following shown on screen. Substituting the known values, we obtain the following shown on screen. Thus, we have the following shown on screen. That is all for lesson 4.5.5. To continue this tutorial, please watch 4.5.6, summarizing the properties of variation. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.